Over the course of the last 11 days of continuous observation, a series of meticulously verified measurements has completely transformed the conceptual framework through which the arrival of 3I Atlas in the inner solar system was interpreted. What was initially regarded as an interstellar visitor on a hyperbolic trajectory, yet another fleeting traveler destined to cross the sun's vicinity only once before vanishing forever into galactic darkness, has exhibited behavior that no known natural dynamics can reproduce. The object executed a sustained deceleration equivalent to approximately 2.8 kilometers per second, a magnitude incompatible with any form of passive gravitational interaction. This prolonged deceleration, achieved without mass loss, without reactive plumes, without external thermal variations, and without the slightest indication of conventional propulsion, has distorted the models describing the motion of gravitationally unbound bodies. The data indicate that the object entered the solar system at a velocity typical of interstellar visitors, a velocity clearly exceeding the required for permanent escape without return. Nevertheless, as it progressed toward the inner regions, the velocity curve began to trace a smooth yet persistent decline. This deceleration does not correlate with friction, heliospheric particle density, or interaction with the solar wind. The most conservative dynamical models predicted that the object should retain its initial velocity or alter it only under the influence of massive bodies during distant encounters. Strikingly, the reduction was not erratic but constant, measured, and distributed almost perfectly across more than 10 days of observation. This continuity prompted analysis of the possibility of an internal mechanism capable of affecting such a significant change. The energy magnitude required to reduce the velocity of an object of this size in deep space is enormous, exceeding the combined energy of all crewed missions launched by humanity in the 20th century. Yet 3I Atlas displayed no temperature increase, no gas ejections, no reflectance changes that could betray an intense thermodynamic process. Instead, a stable transition to a closed orbit was observed, an orbit that now appears precisely tailored around the Sun, as if the object had decided, or had been programmed, to remain in the solar vicinity for an extended period. Orbital models indicate that this orbit is characterized by a series of periodic approaches to the terrestrial region. Although not a dangerously close flyby, the trajectory exhibits a pattern reminiscent of a carefully optimized figure designed to maintain moderate distance while repeating observation cycles. The orbit's orientation suggests a latent purpose, to recurrently position itself where Earth is visible from multiple angles, as though the object required data collection under varying conditions of illumination, inclination, and heliographic alignment. The absence of natural mechanisms capable of explaining this transition has generated concern across multiple agencies. Orbital dynamics teams describe the phenomenon as physically untenable within the traditional framework of celestial mechanics. The observed deceleration demands the existence of an internal system able to generate forces opposing motion without manifesting them in external signals. It is reasonable to assume that an exothermic propulsion system would have left detectable traces in the infrared spectrum. However, the object's thermal records remain remarkably flat, with minimal fluctuations inconsistent with intense activity. Once a stable orbit was achieved, the deceleration ceased abruptly, almost as if the responsible mechanism had completed its task. From that moment, rhythmic pulses began to be detected in the reflected light, periodic modulations that do not correspond to the natural rotation of an irregular body. Preliminary interpretation suggests the presence of flat surfaces capable of coherently reflecting light, surfaces that may adjust their orientation. These pulses are not random. They possess fixed duration, constant intervals, and a repetition too perfect to be attributed to the rotation of a fractured core or ordinary surface irregularities of comets or asteroids. Spectral analyses conducted during the pulses reveal that the object's reflectance undergoes small variations at specific frequencies, as if certain surface regions changed orientation or texture in synchrony with the flashes. These variations, though subtle, are clear enough to suggest deliberate adjustment. If the object's surface consists of alternating smooth zones and structures capable of modulating light, such modulations could correspond to an internal mechanism that synchronizes rotation or reorganizes external orientation according to a pre-established pattern. Another disturbing aspect is that the pulses intensify when the object is in positions of optimal visibility from Earth. Rather than uniform distribution, intensity increases under the best observational conditions, as though the reflected pattern held significance depending on the viewing angle. These modulations may be a byproduct of a purely internal mechanism, yet they could also represent a regulation system designed to optimize orientation relative to a specific point in the solar system. The geopolitical situation has also begun to shift in the face of an object that appears to have executed an unprecedented orbital capture maneuver. The international community has been informed only of external observations, without details regarding the energy magnitude or the nature of the pulses. Nevertheless, internal analyses at scientific agencies reveal growing concern: the presence of an interstellar visitor that has chosen to remain in the solar system, performing impossible maneuvers and generating light pulses with exact periodicity, compels a rethinking of the phenomenon beyond a purely astronomical framework. The rhythmic pulses appear to form part of a sequence that may be linked to an internal mechanism of observation, calibration, or transmission. Each pulse retains a stable waveform structure, indicating that it is not a spontaneous response to external stimuli. Rather, it corresponds to an internal cycle activated only when the object occupies a determined position within its orbit. The possibility that the object is executing a controlled approach routine implies that its presence near Earth could recur periodically, creating recurring windows of mutual observation between the object and our planet. The implications of this dynamic are profound. If 3I Atlas has chosen to remain in the solar system, or if its internal mechanism is programmed to do so, humanity now faces the presence of a new neighbor whose nature remains unknown. The series of pulses, the impossible deceleration, the transition to a stable orbit, and the absence of detectable propulsion constitute a phenomenon that, in its complexity, defies natural explanations and forces consideration of the possibility that we are dealing with a structure possessing purpose beyond mere interstellar drift. Following confirmation of 3I Atlas's transition to a captured orbit, dynamic analysis began to reveal a series of patterns that could not be attributed to random variations in interaction with the solar field. At every point of the recalculated orbit, the object adjusted its motion with precision reminiscent of a navigation system rather than a body subject to natural forces. The trajectory described an elongated loop that repeated its approach to the terrestrial environment with disturbing regularity, as if the orbit had been configured to sustain a surveillance cycle. It was not a simple ellipse, it was a modulated curve whose parameters appeared to re-optimize at each perihelion, correcting minute errors and adjusting inclination to preserve constant planetary visibility. As the days progressed, this optimization became even more evident. Orbital inclination decreased slightly after the first close passage, followed by an almost imperceptible correction of the ascending node angle. Internal simulations demonstrated that such a combination of adjustments would have required a series of calculated impulses equivalent to small continuous maneuvers that no form of sublimation or solar interaction could produce without energetic traces. Yet the object's surface remained completely stable, without signs of thermal activity, damage, or ejection traces. Thermal stability measured in deep infrared contradicted any possibility of a traditional propulsion system. The most recent spectral analysis revealed that during the rhythmic pulses of reflected light, secondary patterns emerge at extremely subtle frequencies, patterns that vary according to the object's orbital position. These variations can be interpreted as internal mechanisms regulating the orientation of reflective surfaces. The pulse shape, constant in duration but variable in intensity, suggests that the object performs rotational adjustments with a specific purpose, perhaps to maintain an optimal reflection level toward a fixed point in space. That point coincides with regions near Earth's orbit, fueling the idea that the object may be executing a continuous observation protocol. Meanwhile, orbital models began to show that the recently adopted stable orbit is not static. It exhibits weak precession, yet one surprisingly aligned with Earth's orbital inclination. This means that in each cycle the object passes through a zone where Earth is visible at a recurring angle, reinforcing the hypothesis of deliberate behavior. The precession does not appear to result from natural interactions, but rather from continuous correction that maintains the orbit in an optimal configuration for repeated approaches. Institutional analyses indicate that these maneuvers require not only monumental energy, but also an internal structure capable of managing such forces without rupture. For a metallic or rocky cometoid, such maneuvers would be equivalent to gravitational leaps without mass dispersion. Yet 3I Atlas not only executed the initial deceleration, it has also maintained perfect structural stability, as if its interior were more resilient or flexible than any previously observed body. The hollow structure hypothesis gains strength, particularly when noting that the reflected pulses may correspond to internal panels that reorient themselves. Such a hollow structure would also explain the object's extraordinary ability to withstand stresses without fragmentation. After the abrupt cessation of deceleration, the light pulses intensified. Each pulse displayed an internal structure that appeared correlated with the object's rotation, yet the relationship was not linear. At certain moments, pulse intensity increased when rotation should have decreased, as if the internal mechanism operated independently of external mass motion. This decoupling between rotation and luminosity suggests the presence of an internal control system that manipulates the reflection pattern without dependence on surface dynamics. Advanced models propose that the core may contain mobile regions that shift to adjust the orientation of flat surfaces or internal facets, thereby altering reflected light toward the observer. As these pulses grew more intense, variations in light polarization began to appear, indicating that the object may be performing orientation feedback through an internal control process. Polarization showed weak but noticeable oscillation synchronized with microvariations in the orbit. These correlations were recorded by precision telescopes in several regions, confirming that light modulation has measurable effects on the object's dynamics. Although these effects were minimal, their coordinated repetition suggests a system capable of reorienting internal masses without external thermal disturbances. Meanwhile, internal reports from space agencies began to exhibit a pattern of growing concern. The presence of an interstellar body that does not depart the solar system but actively adjusts its orbit to remain nearby represents an unprecedented challenge. Analysts describe the situation as the emergence of a new orbital actor, whose logic cannot be explained within the current framework of natural phenomena. The scientific community has begun to re-examine old models that contemplated the possibility of interstellar structures with internal control mechanisms, but until now those models have been sidelined for lack of empirical evidence. 3I Atlas, with its impossible deceleration, stabilized orbit, and rhythmic pulses, has become the first serious candidate for a body capable of performing maneuvers beyond natural behavior. The object does not merely exist within the solar system, it interacts with it, traverses it along specific trajectories, repeats observation cycles, and executes adjustments that fit no known cometary or asteroidal category. This repeated interaction with the terrestrial region suggests that we are witnessing a sustained process, a cycle that repeats and may continue for months or even years. Comparison with previous interstellar visitors has become inevitable. Neither the first interstellar object observed in the 21st century, nor any rock from neighboring systems has demonstrated even a fraction of the maneuverability observed here. Although non-gravitational accelerations were mentioned in those cases, no object has accomplished such a radical change as the transition from a hyperbolic trajectory to a captured orbit, let alone without visible thermal or dynamic signals. This case has unquestionably become the greatest anomaly, forcing a reconsideration of the overall theoretical framework. Analyses also revealed that after orbit establishment, small variations in the object's rotation began to be detected. These variations follow a pattern similar to the light pulses, as if both phenomena were linked by a single internal mechanism. Rotation neither accelerates nor decelerates chaotically. It follows a precise sequence, almost like calibration. Each adjustment has a corresponding light reflection, suggesting a very high degree of synchronization. Such sequential behavior fuels the idea of an internal system that uses light not only to transmit an observable pattern, but also as an indicator of the adjustment process. With the emergence of these patterns, The most widely accepted theoretical model has become that 3I Atlas follows a routine combining observation, orbital calibration, and internal stabilization. The object may optimize its position through a set of maneuvers activated at each close passage cycle. The observed periodicity indicates that the process is not complete. Rather, it appears to be in an initial phase where each cycle repetition offers a new opportunity to adjust the orbit and internal mechanisms. Geopolitical implications have begun to manifest in closed discussions. The presence of an object that appears to have decided, or to demonstrate the result of programming, to remain near Earth is interpreted as a situation escaping human control. Space security services have warned that repeated approaches could generate international tensions, especially if the light patterns begin to exhibit variations interpretable as signals. For now, the official position focuses on continuous observation, but internally it is acknowledged that this prolonged presence necessitates reconsideration of response strategies to non-catalogued phenomena. As observations accumulate, the scientific community is beginning to accept that the object's behavior represents a form of stability uncharacteristic of natural bodies. The initial deceleration, followed by a precise transition to a captured orbit and synchronized light pulses with internal adjustments, suggests a process still evolving. 3I Atlas appears to be in a sustained operational state, executing a cycle that shows no signs of conclusion. And as the object continues to repeat its approaches, the question that begins to arise with insistence is whether its prolonged presence heralds a new phase whose nature remains unknown to us. With a stabilized orbit and light pulses acquiring ever more precise structure, analysis has begun to focus on the long-term consequences of 3I Atlas's permanence in the solar vicinity. Unlike traditional objects governed solely by gravity, this interstellar visitor appears to have adopted a functional position within the solar system, a position optimized in each orbital cycle. The observed pattern suggests that the process has not reached its final phase. On the contrary, each new approach reveals progressive intensification, a maturation of the internal mechanism that continues to reorganize parameters of orientation, rotation, and light modulation at a constant rhythm. The latest models indicate that the adopted orbit allows the object to recurrently return to regions of optimal terrestrial visibility, as if each close passage were an opportunity to adjust behavior and consolidate presence. This repetition has become the central axis of discussion among analysts, for it implies that the trajectory is not random. On the contrary, it follows a logic that optimizes planetary visibility while maintaining the object's stability in a zone of moderate gravitational perturbations. The orbit is neither circular nor elliptical in the conventional sense. It exhibits slight variations modulated by the object's own behavior, variations that appear to synchronize with the light pulses. These pulses have shown increasing complexity. Initially, they consisted solely of variations in reflected intensity, but now they begin to manifest patterns in polarization that seem to respond to changes in the object's position relative to the Sun and Earth. The coincidence between polarization peaks and moments when the object is oriented toward the planet provides evidence that the mechanism responsible for the pulses is not superficial. It originates from an internal system that reorganizes portions of the structure to direct light with precision. Such behavior is unusual even for highly reflective materials, since coordination between rotation, orientation, and reflectance requires a level of structural coherence not observed in natural bodies. Meanwhile, analyses of microorbital corrections continue to reveal the object's surprising ability to maintain its trajectory. Whenever the orbit experiences minimal perturbation, whether from Earth's or the Moon's gravitational influence or even solar wind irregularities, the object appears to compensate through an internal adjustment imperceptible from the outside, redistributing masses. This process implies that the object's interior is not homogeneous. It contains compartments, cavities, or mobile structures that alter the body's inertia without generating thermal energy or visible ejections. The ability to adjust its own orbit via internal mass reconfiguration represents a technology, or natural phenomenon, far surpassing our understanding. As these patterns consolidate, the object's behavior has begun to be interpreted not as an isolated anomaly, but as a coherent sequence constituting an operational cycle. During each orbit, 3I Atlas executes a series of repetitive steps, an orbital adjustment phase, a thermal stabilization phase, an internal reorganization phase, and a period of light pulses that appears to correspond to the moment when Earth is best positioned for observation. This sequence is so consistent that some analyses describe it as a permanence mode, a state the object adopts only after completing the transition from its interstellar motion. The institutional impact of this prolonged permanence is considerable. Internal reports from several agencies indicate that the scientific community has begun to divide into two major currents. The first holds that the object may be in an intensive observation phase of the solar system, using its captured orbit as a platform to study not only Earth but the entire near environment. Within this current, the presence of synchronized pulses is interpreted as a mechanism for analyzing planetary reflectance, atmospheric variations, or even magnetic properties of the terrestrial environment. The second current, more speculative yet increasingly supported by accumulated evidence, considers that the object's permanence may respond to a far more complex protocol that we do not yet fully comprehend. Tracking illumination in the pulses shows that intensity increases at specific orbital moments, especially when Earth occupies determined positions relative to the Sun. This precise synchronization indicates that the object not only orients itself toward the planet, but also modulates light to obtain variations depending on the system's relative position. Detailed analysis of these modulations suggests that the object adjusts its behavior according to changing parameters such as incident solar radiation, reflection angle, or even the distribution of Earth's magnetic field. Such behavior, repeating with almost metronomic precision, suggests that the process continues to advance toward a more complex phase. In parallel, the geopolitical field has become considerably tense due to the presence of this new orbital neighbor. Space agencies acknowledge that we face a situation without precedent, an interstellar object that not only avoids departing the solar system but demonstrates the capacity to remain within it indefinitely. This permanence implies that its presence will be recurrent, with approach cycles observable again and again by ground stations. The fact that the object optimizes its trajectory to sustain these approaches reinforces the sense that the process is not accidental. Each close passage becomes an opportunity to collect new data, and the international community is beginning to perceive that humanity may be observed by a system whose objectives remain unknown to us. At an internal level, analysts have begun to describe the object as an uncatalogued resident of the solar system. This provisional term reflects the need to integrate the presence of 3I Atlas into a framework that contemplates phenomena not corresponding solely to natural objects. The object's permanence implies updating the list of bodies with long-term influence on orbital dynamics, especially if it continues to perform maneuvers capable of minimally altering the local gravitational environment. Although these influences are infinitesimal compared to those of planets or massive asteroids, the mere fact of active maneuvers makes it a dynamic factor whose behavior must be monitored permanently. On the other hand, the light pulses have begun to gradually modify their internal structure. Small variations in duration, polarization, and intensity distribution suggest that the internal mechanism is adapting to a new parameter. This transition is interpreted as a natural process within the object's logic, as though each orbital cycle allowed refinement of the system regulating reflectance. The most recent analyses indicate that this adjustment may be linked to a prolonged learning or calibration phase in which the object modifies parameters according to data collected at each approach. Regarding the internal structure, simulations based on resonances and mass redistributions continue to support the idea that the object contains compartments or cavities acting as mobile counterweights. These counterweights enable changes in rotation, orientation, and trajectory without generating detectable signals in the infrared spectrum. This capability, combined with the absence of thermal emissions, implies that the internal mechanism operates through internal density redistribution, probably exploiting elastic or superconducting properties that permit efficient movements with minimal energy loss. Toward the end of the most recent observation period, the magnitude of the phenomenon began to reveal broader implications. The fact that 3I Atlas has abandoned the category of temporary visitor to become a prolonged resident implies a profound shift in the perception of the solar environment. The captured orbit, coherent pulses, and active internal reorganization constitute a body of evidence that cannot be attributed to a transitory process. On the contrary, they suggest the presence of an operational system that has found favorable conditions to remain and continue its adjustment sequence. With this, the analysis concludes that the object's permanence inaugurates a new stage in scientific observation, a stage in which an interstellar visitor does not merely traverse the solar system but adopts a stable position within it. The approach cycles, light modulations, and internal reorganization indicate that the process has not yet reached its definitive phase. Everything suggests that the behavior will continue to evolve, that upcoming cycles will reveal new manifestations, and that humanity must prepare to coexist with a phenomenon whose internal logic remains to be deciphered.